Hi and welcome back to another ComfyUI tutorial. Today is a special day because we're going to combine our skills from previous videos to create the ultimate fully customizable AI model. In this video, we'll cover how to get a digital model's face, choose the right pose, set up the background, and dress up our model. Then we'll improve the face and, as a bonus, enhance the hands. I'll explain each step and every node in detail, and you'll find all the resources in the description box. If you're new here, don't forget to like and subscribe. Now let's get started. First, we'll generate a face for your digital model. This is all about personal preference. You can create a face from scratch just like I did. Here, I'm using the RealVis XL version 4.0 Lightning Checkpoint model. The prompt should be a close-up photo that details your desired facial features. I'm creating a batch of 4 images, which I'll use later with the IP adapter. Additionally, I'm using the Image Save node from the WAS node suite to save the generated images to a specific path. Start a new workflow using the RealVis XL checkpoint model. From the Inspire Pack nodes, open Load Image Batch from Deer to import all the face images we generated and saved. Just enter the path here. Next, load the IP adapter and connect it to the batch images, our model, and the case sampler. Set the denoise strength to 0.75. For the image dimensions, set the width to 832 and the height to 1216. Now we need to set up our open pose. Load the image that has the pose you want to replicate. Use the DW preprocessor from the ControlNet Auxiliary preprocessors group. We'll also need the Apply ControlNet Advanced node. Load the ControlNet model, in our case, it's OpenPose XL2, and connect it with our positive and negative prompts and the case sampler. Make sure to disable the face and hands in the OpenPose to give the model freedom in those parts. Before generating, let me share the simple and generic prompt I'm using. Since we want our digital model to wear a desired short-sleeve top, it's easiest to give it a short-sleeve t-shirt now. This will look better when we use IDM VTON in upcoming steps. Also, use the plus face model instead of the plus model in IP adapter. Let's generate 4 images and see the result. As you can see, the pose is correct, which means our open pose nodes are working properly. For the background, simply change it in the prompt. Nothing complicated here. A handy trick is to use a fixed seed to better control the outcome. Start by generating a batch of 4 images at once. This speeds up finding the best result. By changing the seed number and running a few more generations, I found an image in the batch that I'm happy with. To select this image, use an image from batch node. Remember, index 0 means the first image, so if we're picking the second image, its index will be 1. Perfect. There are 2 methods to make our model wear the target garment. The best way is to use IDM VTON within ComfyUI, which I explained in detail in my last video. However, this method needs a lot of GPU power and might not work for everyone. The good news is, you can use the IDM VTON web demo on Hugging Face for the same results, and that's what we'll do. First, export your generated image and edit it using an image editor like Photopea. Create a new project with dimensions 768 by 1024, which is the resolution required by IDM VTON. Copy and paste your image into the new project. Resize it to fit the canvas and save it in 768 by 1024 resolution. Next, open the IDM VTON online demo on Hugging Face. Links will be in the description. Load your digital model and the target garment. For example, describe it as a short-sleeve t-shirt. Uncheck the auto mask and use the brush to manually mask the t-shirt for more precision. Now, generate the image. Change the seed number and keep generating until you're happy with the result. Once done, download the image. Here's our model in the target clothing, looking great already. There are still things we can improve that simple upscaling won't fix, so let's move to the next step. To enhance the face, we'll use in-painting with the help of IP adapter. Pay close attention because we're going to unleash an amazing trick for the best quality possible. First, add a face-bounding box node from Face Analysis in ComfyUI. This detects and crops the face in your image. Use Insight Face as the face analysis model. I'll link a guide below for installing it since it can be tricky. Next, use the Image Resize node from ComfyUI Essentials. Set the width to match your image width, height to 0. Choose Lanczos for interpolation and enable Keep Proportion. Previewing these nodes, you'll see the face detected. It's close, but adjust the padding percent to 0.6 to give it some space. Moving forward, add a VAE encode and connect it with a Set Latent Noise Mask node. Mask the face, including the hair, but avoid the edges. Use a Gaussian blur mask to soften the edges, making the final output look well fused. Next, add a clip text encoder node and write the positive prompt, "Blonde, beautiful face." Let's copy the previously used K sampler by holding Ctrl+ Shift+ V to paste it with all pipelines connected. Connect the clip text encoder and enable the IP adapter plus face. This will help us bring back our face features since the face is now closer. Set the denoise strength to 0.5. And don't forget to connect the clip with the text encoder node and also the latent noise mask with the K sampler. Now, our face matches the source model and looks much better. Now let's place the improved face smoothly on top of our original image. First, let's create an image resize node to return our image to its original size using the face analysis node. Now we convert the width and height to inputs. And connect them with face analysis, original image width and height. Next, we load the image composite masked node, and we connect the face image as the source. The original image as the destination, and the blurred mask we made earlier. Also, we need to convert the X and Y coordinates to inputs, and link the original X and Y from the face analysis node. Using a preview bridged, we can now see the result. Preview the result, and you'll see our AI model's face is now highly detailed and closely resembles the source images. The most frustrating part about AI image generation is hands, and it takes a lot of effort to get them right. But I'm going to show you a great method that really helps. First, we'll use a similar method to what we did for the face. Since we can detect hands, we'll manually crop them using the image crop node from ComfyUI Essentials. Locate the hand position, keeping the width and height at 256 pixels. Adjust until you get the hand cropped correctly. Now that the image is 256 by 256, we need to upscale it by 4 to get it to 1024 by 1024 for use with the SD-XL model. If you want to use an SD 1.5 checkpoint model, upscale by only 2 to make it 512 by 512. This applies to face improvement too. Next, we use the Mesh Graphomer Hand Refiner from ControlNet Auxiliary Processors. This node detects the hand and creates a mask and depth image with the correct number of fingers and position. Connect this node to an Apply ControlNet Advanced node. For the positive prompt, type hand. Load a depth model called Zoe Depth Model for SD-XL. If you're using SD 1.5, use other recommended depth models, which will be linked below. Place these models in your ControlNet folder in the Models directory. Add a K-sampler and connect it with the Apply ControlNet and your checkpoint model. For the latent, bring in a Set Latent Noise Mask. Convert the hand image to a latent image and connect it with the samples. Also, use the mask created by Mesh Graphomer Hand Refiner and add a bit of Gaussian blur before connecting it with the Set Latent Noise Mask node. Don't forget to connect the clip and the image from the Mesh Graphomer node. Generate with a 0.5 denoise strength and check the result. The hand should look much better now. Adjust the denoise strength between 0.4 and 0.5 and play with the seed number until you get a well-structured hand that you're happy with. Now let's bring this image back to the entire model's image. Scale the image down by 4, which means 25%, load an image composite masked. The destination should be the entire model image with the improved face, and the source should be the downscaled hand image using the mask from the mesh graphomer. Convert the X and Y inputs and connect them with the original from the image crop node. To further improve, create a new mask, smooth it with Gaussian blur, and connect it to the image composite masked node. Now, you have a well-refined hand. By comparing the image from the beginning with the modified one, you can see the improvements in the digital model's face, pose, background, and clothing. We also fixed the face and hands. If you liked this tutorial, don't forget to like, share, and subscribe. You can find the workflow used in this video, the custom nodes, and prompts in the description below. See you in the next video.